now I'm coming from textile engineering industry, and there are textile engineering and manufacturing industry in textile. These two industries are under different ministries. So if any development has to be taken for textile engineering for machines, we have to go to Ministry of Heavy Industry. And the development in fiber and fabric, that is mills, we have to go to Ministry of Textile. So bringing them together on one platform is very, very difficult. And that is what needed if you want some development and automation on the shop floor of user industry. So ITAMMA, I'm working with ITAMMA as a Director General Technical since last 20 years. And before that, I had worked with Mhatre for 23 years. And I have worked for both the industry. I'm trying my level best to bring both the industries on the same platform so that we can do some, we can understand each other and the development can be very easy. Now, before I start this, let me make it very clear that people are afraid or people are having a fear in their mind that AI will take away the jobs. Because textile industry is a manpower oriented industry. There are a lot of manpower in textile industry. So when this fear goes, it's a very difficult situation to us to introduce some automation or artificial or intelligence. So I have categorized my presentation in 4 important titles. Now let us see how can AI and automation improve efficiency and quality and productivity on the production shop floor. Now we have seen in textile industry, if there is a fault in the machine, this is the loom where viewer is attending the machine. Today we have seen machine vision inspection. It is enhancing the quality control and consistency. High-speed cameras powered by AI detect minute faults like color inconsistency, weaving irregularities or stains in real time, which often reaching 98% accuracy compared to lower manual rates. So Ritter is the company which has these gadgets on the loom for fabric inspection. Coming to the next, improved production efficiency. There is one more gadget which is developed like load cells on backrest. This gives the predictive maintenance. Sensors track machine health in real time, predicting failures before they occur and reducing unplanned downtime by up to 30%. A process optimization, if you see AI adjusts machinery parameters such as speed, temperature, and material load to achieve maximum output with minimum energy usage. These are the development which we see on the loops at the backrest. Automation of labor intensive tasks. We have seen in garment, there is a lot of labor used in garment. If you see for each garment machine, one labor is involved or at least on sewing machine. So robotic system now has been introduced on handling repetitive complex tasks such as cutting, stitching and pocket weld attachment in apparel manufacturing. So we see that robotic cutting and sewing systems along with the automated sewing detection, missing buttons, misaligned seams, etc. are becoming common now. Now coming to the other side of the game where we see operation 24/7. If you have seen in European countries, many machines, many factories are running 24/7 and they don't require any human being to attend. So these are the technologies which are introduced, like automated systems allow factories to run continuously with minimum human supervision, increasing overall output. So automatic web repairs or web transfers on shuttleless looms are there. Then we have seen new vacuum cleaning system which is integrated in-house in the factory. So no human being is required to cleaning activities. Then we have seen there is also a quick style change concept where we change the style. Here left hand side you can see the human being attending the loom along with the machine, but right hand side no human being is required, and this concept enables a single operator to change weaving style in 40 minutes by swapping essential parts like warp beam, backrest and harness. We have also seen that previously the lubrication was taken on the open oil by human being or with small gadgets. But today we see the reservoirs. You can see the reservoirs are attached on the machine itself or oil baths. But again, when they are in the closed section, there is a question mark how you will assess the uh, oil, whether oil has reached to the changing frequency, we don't know. So small sensors are used, which shows the colors of the oil. When the color is changed, you come to know that oil is deteriorated and it has to be removed. Uh, how can, second point is, how can robotics and automation be integrated into existing operation with minimal disruption? See, instead of total overall, introduce robots in specific high impact areas, like use modular flexible systems that can be adjusted or scaled as needed without major downtime. Implement cobots which are designed to work safely alongside humans, eliminating the need for expensive safety cages and allowing for easy deployment into existing human workspaces. Map existing workflows to identify specific bottlenecks, inefficiencies, and repetitive tasks suitable for automation, ensuring that only necessary tasks are automated, reducing potential chaos, and use digital twins to simulate and validate the performance of robotic systems before physical deployment, identifying issues earlier. Instead of replacing old machinery, retrofit. Now, retrofitting is also very important. Uh, it with PLCs, programmable logic controllers, and HMIS, human machine interfaces, to ensure capability with new robotic system. Now, skilling and reskilling, we have seen continuous skill development programs are essential, and virtual training is very, very essential nowadays. You cannot send every time the person on the factory and get the production stop and give training. So virtual training is in full form today. Safety is also very important, where AI can be used in safety. We have seen the safety guards, left hand side, the lady is standing without any tension on the machine itself, where safety guard is there, which is in red color. And right hand side, we see that automation is there, where we need not have to lift the heavy rolls. When we are going for a high speed machine, the weight of the product which has been enrolled, winded on the beams is very high. Its weight is more than tons, so it cannot be lifted by human being. So automation is there. Now, what are the key challenges in adopting AI-driven automation, and how can they be addressed? Advanced robotics and AI software require significant capital investment. We all are knowing capital investment is very high, it is required. Many textile factories rely on older non-digital machines that are difficult to connect with modern AI system. A lack of personnel who understand both textile manufacturing and AI technology makes implementation very difficult. AI requires massive data sets to function effectively, but many factories have fragmented or unorganized data. Traditional manufacturing practices can lead to employee resistance due to fears of job displacement. Now, addressing these challenges, we can start with small, high-impact AI pilots, computer vision for quality control, what we have seen in the previous slide, to prove ROI before investing in large-scale plant. Instead of replacing workers, focus on training that to manage, maintain, and work alongside AI system, facilitating a smooth transition. Then retrofit legacy machinery with industrial Internet of Things, IIoT sensors to gather necessary data for AI system. Establish strong data governance to ensure data is clean, consistent, and collected securely from production line. Work with AI specialized firm to bridge the skills gap and provide tailored solutions for textile production needs. Now, agility and supply chain transparency. Here is a very good development which has taken place, where you have to just put the labels and it shows you, you tells you from where the fiber, yarn, fabric, and garment is been located. From where the fiber was available, yarn is been tracked, and then fabric and garment. So this is a technology ensure transparency and verify sustainability claims from raw material to finished product. And these are the advantages. Now, which technology will define the next phase of industrial manufacturing? The next phase of industrial manufacturing in the textile industry is defined by a shift from manual, labor-intensive process towards digitally enabled, sustainable, and highly automated ecosystem, which is in 4.0 and 5.0. This transformation is driven by the need for faster turnaround, customization, reduce environmental impact, and supply chain transparency. Now we have our members like Reshmi who has already implemented IoT and they are getting a lot of good efficiency. Clifton Export has embraced Industry 4.0 and they have given the green tag also. We have Jumac Industry, Jumac, our member, who has data-backed automation and centralized control, smarter spinning mills with decision-making tools and increased data transparency. According to them, recently published report implements that latest IoT tools can improve mill productivity, time-to-time market up to 25%. We also have Rimtex. They have sliver loading technology, increase yield by more than 10% without changes in machinery, equipment and sliver can dimensions. So has also helped open and spinning segment to generate up to 10% more sliver space. Same can be sliver space with same can dimensions. New sliver boat is also developed, autonomous mobile robot for sliver can navigation for hassle-free transportation of large diameter sliver cans, minimize manual labor, human errors, and reduce downtime, making production more efficient and profitable. Designed X-axis to offer new perspective selection combination of extensa rings and extend travelers, improve yarn consistency. We also have single axle caster wheels. Calipers have come out with which prevents accumulation of dirt and fluff on wheels, ensures stoppage-free operation and securing sliver from breakage during movement and reduce manual labor required for caster cleaning. Thank you.